Hey there and welcome to Easy Game Art. In this new episode, we're going to take all of the previously created assets from the last 4 episodes and put it into an actual 2D platformer game. So we're going to be using Unity just because it's very quick and efficient to create simple 2D games with it, and it also provides a lot of nice tools for 2D sprites, animations, and so on. So since we've started this series with the graphics for our little character here, I thought we'll also start the Unity part with the character. So this episode we're actually going to put the character into the game, do skeletal animation on our character, and create a basic script for a character controller for our 2D platformer. So let's jump right into it. Okay, so before we go into the Unity part, we actually have to export our character graphics first. And in order to do that, we have to prepare it a little bit. So as I've told you in the first episode of this series, vector graphics eventually have to be rasterized because most game engines cannot really deal with SVG, with vector graphics directly. It's also more efficient and so on. So raster graphics in the end have a lot of advantages when it comes to rendering. So in order to do this, we have to export our vector graphics back into actual PNG raster graphics. And also, I've told you before, we are going to do skeletal animation on our character, which means that we'll create a skeleton of our character. So in order to do that, we have to separate the body parts because we cannot just use one layer of rasterized graphics for this. So the first part is to actually take our character apart. There are different ways, obviously, depending on your character and also the level of detail you want in your animations of the number of body parts you want to separate. But there are a few common practices, and I generally separate the arms into 3 parts. So the upper arm, the lower arm, and the hands. Although the 2 arms look very similar, I'll still do 2 versions of that. Okay, then the torso should be a separate part, as well as the neck and the head, obviously. So we'll continue by grouping the entire head and putting it a little bit on top. The neck should be separate, and the torso. Obviously, the X is a little bit special, but it's also supposed to be a separate bone. So we'll just put that up somewhere here. And then the legs. I'm also going to do 3 parts for the legs, so upper leg, lower leg, and foot. Okay, so if it looks somewhat like that, it should be fine. So it doesn't really matter now because in the end we have to assemble it back anyway. Just make sure that there are no overlaps of the individual body parts. And also one little thing I will do is to actually round up the joints a little bit. So basically all of the body parts which will be joined and which will rotate later on in the animation, it is good to have some extra space to overlap, because that way we won't get any blank areas later on when we animate. Okay, and finally we're going to duplicate that skirt. Maybe change the color a little bit for the left foot. Okay, so our character is prepared. The next thing is to create a new Unity 2D project. So in my Unity hub, I am going to create a new project. I'm going to use a little older version because I've had some troubles with the 2D skeletal animation. So I'm using 2.18.3.14. Unfortunately, I'm not entirely sure with what versions the package works, but I can definitely confirm that it works for most 2.18.3 versions. So yeah, as template we select 2D. We called it Prehistoria, right? So we'll just hit create. Okay, and when this is done, we have our blank 2D project. So the next thing is to go to Window Package Manager. And then here you have to go to Advanced Show Preview Packages, since this 2D animation toolkit is still in preview, at least in this version. And then you go to 2D animation and click Install. Okay, and when this is done, you can close this. And then actually the next step is already to include our character. So we'll just go back to Inkscape and actually do the export now. So just hit Control-Shift-E or go to File, Export PNG image. And then you get this dialog here. The only thing here you have to take into consideration is the resolution of the export. So if you want to run your game full screen with 1080, let's say, and your character maybe takes up at most half of the display, then it's definitely enough if the height here in this case is, yeah, let's say 800 maybe. Although actually let's double this up, because anyway the graphics file will take up very little space, so it doesn't really matter. And because it could be a little bit of a hassle if you have to change this later on after you've already done all your animations and so on. Okay, so I've exported it as a PNG, and now I can just drag it in here. Let's do a little bit of folder structure beforehand. So let's make a folder character and put this in here. Okay, now here is your actual texture. Since this is a 2D Unity project, by default, all of the textures are actually treated as sprites already here. So you don't have to do anything here in this import settings. So you just have to go here to the sprite editor, which opens a new window. So I like to put this window somewhere here maybe. And here in the sprite editor, if you have installed the 2D animation package, there's another menu point skinning editor, which is actually now where we are creating our 2D character rig. Okay, so the next thing we do is to actually create a skeleton for our character. But before we create the bones, I think it's important to first create the geometry. So I've had a few problems where the automatic weight painting didn't work later on. So I think it's because you have to first generate the geometry. I'm not sure though. So let's tick off weights here. Leave the other values of something default. It doesn't really matter. And then hit generate for all visible. So that created the outlines for our character. Okay, then we go to create bone. And now we can actually draw up our skeleton. So when you double click somewhere here, you select the entire sprite, the entire texture, and then you have this red outline. Okay, so when you do a left click here, we can actually place the root bone. The root bone is usually somewhere near the hips. So I'll just put it here, and then then you can actually select how far or where the bone should end. So I'll put this here, and after that you can immediately place a connecting bone from there. So I'll place the next one here, and then I'll hit escape. And now since we want to connect the rest of the body parts not directly, but as child components as child bones, we can select this one by left clicking again, and then you have like this transparent view of the next bone, and you can again left click to place this one, and then put it somewhere else, and then you actually have a loose connection between those two. So this is the child of this one, and we can later arrange this in the scene then. So let's just continue with the same process for the entire body. Okay, I think we're done. It can be a little hard at the beginning to not make any mistakes with the skeleton, but if you notice later on that there are a few issues, you can always go back here and edit the bones. Okay, I had to fix a little connection here. So this one was actually parented to this bone, which kind of broke something, so I changed that. Anyway, the next part is then to go to auto geometry, select all the bones, and then make sure that weights is checked here this time, and then hit generate for selected. Okay, now this should have auto-generated the weight for us. So the weight defines basically which part of the sprite is affected by which bones of the skeleton. So if we go back to preview pose now and start to actually move some of or rotate some of those, we can see that the textures are now moving with the skeleton. So that is what we want. Click reset pose again. And now we are actually done with the rigging part. Now we can actually go back to our scene and insert our character. So since the rig is done here, or actually one thing I forgot, you have to hit apply here. Very important, otherwise it doesn't save the changes. Okay, so now you can just drag and drop the character in here. So obviously it doesn't look right. We still have to rearrange our body parts. First part here is now to add a script component, which is called sprite skin. So you should find it here. It's part of the 2D animation package. Then here you can click create bones, which will automatically fill those in for you. And now we can already see our skeleton here. So basically now we have to readjust the positions of all these nodes to fit our character again. With this handle here, you can transform the position. So yeah, it's a little bit of a hassle again, but I haven't found a better way to do this. If you want to get rid of the bones, by the way, you can select the outer game object here and just collapse the sprite skin script. And if you expand it again, you can toggle it. Okay, now you notice here that there are a few problems with the drawing order. So we can easily fix that by going back to the sprite editor and then selecting the bones and changing the depth here. So where are the problems? So obviously these have to be behind. So these have a depth of -1, let's say. Whereas these have a depth of 1. And the same for the legs. Then the neck should be behind the torso, but also behind the head. So let's give this -1. And I think the head should be fine with 0. And the X should be behind this one even. So let's give this a -2. Then hit apply again and see if it works. Okay, there's still one issue with those two. So let's give the arm actually 2. Okay, now it looks alright. So now if we expand the sprite skin again, we can actually modify the nodes here and see how that already affects our character. So far it looks sort of alright. So there shouldn't be any big problems with the skeleton, I think. So let's go back to the original pose. And now the next part is to actually create and define the animations. So we are going to do an idle animation, a run animation, and a jump animation. So for that, we create, we right click here in the Project Explorer and go to create new animation. We call this first one idle. And then we drag the idle animation on top of that character object here. So this has created now a character animation controller and also added the animator component here. So if we double click on the character, it opens up the animator, which is basically the animation graph where you can define a state machine, in what order and in what after what events which of the animations are played. So for now we just have the idle animation here, which is played by default. Let's go back to the scene and go to the animation window now. So if you don't have this, you can open this up with window animation here, and then actually select in the scene graph the character. And now you should have the idle animation here, since it lists all of the animations that are part of the character's animator. And now we can actually create our idle animation. So it's pretty similar to other tools where you animate something with keyframes if you have used some other tools before. So basically, the way I do it is I first enable auto keyframe or keyframe recording mode. This way all of the changes are immediately reflected, so are immediately created keyframes for at the current position I have my cursor at. So yeah, basically for the idle animation, I just create some very minimal movement. So I go to some position, maybe 30, and move the boards accordingly. So yeah, just some very simplistic movement. And for the idle animation then, I copy the first set of keyframes to the end of the animation. So that way it repeats. Basically, it goes to this state and then goes to the initial state again, and then repeats itself. So it's a little bit too fast, so let's just move this a little further out of the way. Let's disable this for now, and in order to create the next animation, we can just hit create new clip here now, and let's do the run animation next. And basically same principle. Now for the run animation, it can be a little tricky. I'm not an animator either, obviously, so I'll just use a little bit of reference in order to get this somewhat right. Okay, I think that already looks decent, let's say. It's definitely not perfect, but as I said, the point here is not to have a professional animation, but rather to show you the concept. So I think it's fine for now. So final animation is the jump animation, which is easier again, I would say. So for the jump animation, I just create 2 frames. Yeah, I don't know if that works, but let's see how it looks in action. Now, if we scale our character down maybe a little bit, because, yeah, if we then hit play now, we should already see the idle animation. Yeah, because that is the default animation. Okay, it doesn't loop, so let's fix that quickly. Here in the animation asset of idle, you can check loop time, and that will loop forever then. Yes. Okay. So since in the animator graph the idle animation is the default animation, it does just play this one forever from the beginning on. But as you can see here, it has already added the other 2 as well. So the next thing we'll do is to actually wire those together. But before we can do this in a meaningful way, we have to create our script, which controls the movement and so on of our character. So for that, we'll have to do a little bit of programming quickly. Nothing too complicated though. So let's create a new C# script here. Let's call this character controller and open it up. Okay, so before we'll start coding, we'll actually add a few more components to our character. So we're going to use the physics engine. So we're going to attach a rigid body 2D component in order to be a physics component, a physics body. And then we'll also need a collider, a box collider 2D. So the collider is obviously not perfectly recognized, so we have to set it manually. Okay. Yeah, we'll tweak a few of the physics of the rigid body values later, but for now that's fine. So let's go back to the script and let's reference the rigid body first. And let's also reference the animator, because we need to set some variables of the animator in the script. And finally, we'll need the sprite renderer later on, mainly for flipping the sprite when we actually turn around. Okay, so basically for movement, we won't use the update method, but we will use the fixed update method, which is also built in. The difference is it has a fixed frame rate. So for most kind of physics related stuff, you want to use the fixed update method. And in our case, we have to manipulate the rigid body a little bit. So this is definitely something which we'll do in the fixed update in that case. So yeah, let's start with the basic movement. Yeah, let's create a separate move method for that. And basically, first we'll take the input, the horizontal input to be used for left and right movement. So we'll just store this as the velocity for now, which is then the input axis horizontal. And we'll just multiply this with some speed. So we need a variable which we can set then later on in the editor. So let's do a public float, speed, which we'll set to some random value for now. I don't know yet which we're going to need. And then we are going to need some jumping Boolean variable, which is bound to the not to the horizontal axis, but to the space button for now. So get key space. Okay, so the first thing we're going to do is to set the speed variable in the animator, because we'll need that to figure out if the idle animation or the run animation should be played. So with animator.set float, we can set a float variable. We'll define that variable later on in the editor, in the animator. So yeah, we'll set this to the velocity, but actually to the absolute, because we don't really care for the animator in which direction we're running. Okay, and then for the basic movement, we basically set the velocity of the rigid body directly. There are a lot of different ways to do this, but I'll just go for that way. And we are basically going to set it to the velocity, but actually we want some kind of smoothing. So there's vector2.smooth damp. So it feels a little smoother if we take this damping method. So this should be the velocity. The target should be the new vector with our new velocity, which is the float from the beginning, and the old y velocity. Okay, then we need a ref variable as a current velocity, so we'll just create a member variable here for that. I don't think we need it, but I'm not sure yet. And the smooth time, I think something like that. So not too much. Okay, so this should already do the basic movement in horizontal direction. So now for the vertical direction. So we want to add a new Boolean is on ground, which we'll later set in the ground collision detection. Also, what we're going to need is another public variable which we want to set in the editor, which is the jump force. And we are going to need some kind of drag in the air. Let's call this air drag. and set this something like that. We want to initiate a jump when we are on the ground and when the spacebar is hit, so when is jumping is true here. Then we first set the animator. This time it's going to be a pool, so is jumping, let's call it like that. And this is set to true in that case, so this will initiate the jump animation. And in that case then is on ground is set to false. And to have the actual movement, we want to this time set a force actually, not set the velocity directly. This is going to be a vertical only force, so 0 in horizontal, and the jump force in vertical direction. One more thing, we want to cancel the jump when we're not on the ground and when we're not jumping. And if the body velocity, the vertical body velocity is greater than 0, 0, 1, so, or just 0, let's do 0, 0, 0, 1. So basically, if we are still rising up, this is what that term says. And then we want to cancel the jump, so body.velocity equals new vector, body velocity x, and just some damping factor here again to have some kind of smooth canceling. Yeah, something like that. And the last thing to put here, or actually the air drag, I think we have to put it here. So if we are not on ground, we want to add the air drag to the velocity basically. So this way we have a different horizontal force also if we are in the air than on the ground. The flipping, so if we turn around, basically the sprite renderer should just split or flip the sprite in x direction. If velocity is less than 0, it should flip, I think. Yeah, should be fine. Flip x equals true. And if not, or actually, if not, because if it's standing still, it should just remain in the same direction. So if the velocity is actually greater, then we want to have the opposite here. Yes. So now we have to set the is on ground variable. Therefore, we create a handle collisions method, and in this method we want to check if we have landed. So if we have hit a solid object, a collider. Let's do a temporary variable was on ground, which is first set to the current state of is on ground. Is on ground is set to false in that case first. And then let's do a physics 2D actually overlap circle all. Okay, and now we need one more variable, which is going to be a transform which tells us at what point the bottom of the character actually is. So we can set this in the editor later as well. So this is going to be another public, a transform. Let's call it bottom transform. And we'll use the position of that one here. Also the radius, I think I had something like 0.6, that should be fine. This is the radius of the circle where the collision detection takes place. And I think this returns, this returns a list of an array of colliders 2D. And now we can just iterate over those colliders. And we have to check if, I think we have to check if it's not us. So if it's not the player itself where the overlap happens. So if collider game object is not equal to our game object, then we've actually hit something. So is on ground equals true. And we could also trigger some landing here, but I think there was some problem. So I think I have to check first if, so if I was not on ground, and oh yeah, I have to check the previous position. So I have to know if I'm actually falling. Otherwise there are issues to actually rise up from the ground, so you might get stuck and so on. So a few issues arise. So I'll just do this check. I'll just add this check here. So for that, I actually need the previous position y. So this is just set at the end of the update method. And now I can check here whether the previous position y is greater than the current position, which would mean that we're actually falling, which would mean that now the landing event can be triggered. Let's just create a method here, handle landing, which we'll call in that case here. And if we land it, we can actually set the boolean is jumping to false for the animator. Okay, now let's see. I think... Oh, okay, we have to call these two methods obviously here in the fixed update. So move and handle collisions. But otherwise, I think we are pretty much done with the script. So let's go back to Unity. And here we are going to drag our script. And yeah, I think these values have to be tweaked then probably. Okay, we have to set the bottom transform. So I guess some of those, yeah, let's just use this bone here. So it's just for the position and it should be somewhere near the legs, so this should be fine. Yeah, so let's add some ground for the character to actually stand on. So I've just added a blank texture basically because in Unity all of the sprites need to have some kind of texture, even if it's just a rectangle. Yeah, so we can set a color on this as well. It's just a placeholder anyway. Okay, and then we have to add a box collider as well here. Let's maybe add another one here. Okay, I think the character should be fine. Let's hit start and see what happens. Oh, okay, so a few issues. Obviously, the speed is too high. And of course, we need to set the animation parameters. I've totally forgot about that. Let's set the speed a little lower. So maybe 10. Also, in order to prevent rotation of the entire thing, we can set the constraints in the rigid body 2D to freeze rotation C. Okay, and then obviously the animations, the animation transitions. So in the animator, we have to define when the character should switch from idle to run and from idle to jump and whatever combinations there are possible. So basically, let's start with idle to run. So there are both ways. We transition from idle to run. So if we click on that arrow, we can actually define when the transitioning should take place. So here we can define a list of conditions. But before we have to define the parameters. So in the code, we have defined two parameters, which are the speed of the player and also a boolean is jumping. So we'll create a float speed and we'll create a boolean is jumping. All right, and now back to the transition, we can now select one of the variables here. Let's do speed. So in order to go from idle to run, the player should have a speed greater than maybe 0.1. Also, we can here define that the transition, the way the transition takes place and so on, so duration and so on, but we actually don't want to have any transition durations. We want it to happen immediately. So also exit time we'll disable. And then we want to have a transition from run back to idle. And that should happen when the speed is less than 0.1. Okay, and also let's disable these here. And for the jumping, we want to have a transition from any state actually. So both from idle and run. So we'll make a transition here. And the conditions here are the Boolean variable is jumping. if it's true, yes, fine. Also no duration, okay. And then from jump, we have either a transition back to idle, or we have a direct transition back to run, and the difference is just the speed again. So basically, in both cases, the condition is that is jumping is false, and we can have another condition. In that case, if the speed is less than, again, let's use 0.1, then it should transition back straight into idle, and otherwise it should transition back into run. Okay, I think that should be it. Let's try. Okay, the speed is still pretty high, but it's visible. The run animation doesn't look great, but it doesn't look too bad either, I think. Okay, and the jumping works, and landing as well, perfect. So let's increase the gravity a little bit, otherwise it's very much floating. So in order to do that, we'll go to our rigid body component. Let's do gravity scale of maybe 4. Let's see. Okay, it's a little bit too much now. So maybe either increase the jump force or decrease the gravity. Let's do 3 here. And decrease the jumping speed a little bit. And maybe actually the character is a little bit too big, I think. So let's scale it down. Oh, we're on the game view. Okay, I think it's better. So let's see if the values are still good now. Okay, now the jumping is again way too high. But otherwise, I think the jumping system works pretty well because it actually cancels the jump. Yeah, it cancels the jump when we release the spacebar, which is exactly what I wanted, to have more control over the jump. Let's increase the gravity scale again to 4. Maybe that's already enough. It's still a pretty high jump, but it feels way better now. Now actually the running is a little bit too slow. I'm going to tweak the values a little bit. You can do that for your own, obviously. It very much depends on how you like your 2D platformer controls. Anyway, I think we're done with our goals for today. So we have created this pretty nice animations for our 2D character, which we've created in the very first episode of this series. So with Unity's 2D skeletal animation tools, it is really quick actually achieve these kind of animations, and it has a lot of advantages, obviously, in comparison to maybe sprite sheets. Obviously, it saves a lot of memory. It's also very dynamic, so you can for instance replace the eggs dynamically at any given time and still include it in the animation. And there are a lot more things you can do with skeletal animations. So this is very flexible and very quick to do, I think. Okay, so I hope to see you next time when we are continuing with this little 2D platformer, and we're going to add probably the rest of our created assets. So the foreground and background definitely, maybe even already the title screen. So yeah, I think it will look pretty nice in the end. And until then, have fun creating your graphics and your game. Bye.